memoryless, no memory. So output at any instant, it depends only on present input and it cannot depend on past input value because it does not have any memory. Whereas dynamic, it is a memory system. So output at any instant of time, it depends on present as well as past. Okay. Let us see examples. It will be even more clear to you. Okay. Let us consider the system equation. Okay. Y of n equal to x of n plus x of n minus 1 plus x of n minus 2. If the ask is to find whether this is a static system or dynamic system, how to proceed, let us see. Okay. Let us pass the values n equal to 0, minus 1, 1, 2, minus 2. Okay. First, let me pass n is equal to 0 in the above equation. Y of 0 equal to x of 0 plus x of, when I put 0 in place of n, what I get? 0 minus 1 plus x of 0 minus 2. Okay, you just resolve this. X of 0 plus x of minus 1 plus x of 0 minus 2, you get minus 2. Right? See, output, y, we already know this, right? Y is nothing but output and x, it denotes input, right? See, if you see here, output 0, it depends on present. 0 is present, right? For 0, 0 is present. Minus 1 is passed to 0. Okay, maybe in graph if you see, it will be like this, right? So 0, output is here. Okay, it depends on present input 0 and it also depends on minus 1 and minus 2. Okay, so x of minus 1 and x of minus 2, it denotes past input values, right? You get it, right? So this particular system, it is a dynamic system because output, it depends on present input and also it depends on past input. Okay, hence I am concluding this particular system as dynamic system. Okay, and when you get the answer, there is no, when you find out that it is a dynamic system, there is no need to proceed further. You can stop here and conclude this particular system as dynamic system. Okay, and if it is a static system, okay, for example, if you get the result is a static system, when you put n is equal to 0, it is always better to give all the values minus 1, 1, 2, minus 2, and after that you have to conclude if it is a static system or not. Okay, maybe in further examples it will be even more clear. Pay little attention. Okay, now the second system equation is this. Y of n equal to 2 into x of n. Okay, so the question is whether the system is a static system or a dynamic system. So what we need to do, we have to pass the values for 1, n, right? So when n is equal to 0, what you get? Y of 0 equal to 2 into x of 0. See, output, it depends on present input only. 0, 0. So it depends on present input. So static. Now again you pass another value. N is equal to 1. What you get? Y of 1 equal to 2 into x of 1. When you pass n equal to minus 1, what you get? 2 into x of minus 1. Okay, even for 2 and minus 2, you will get 2 into x of 2 and 2 into x of minus 2. So it is very clear that this particular system is a static system. Okay, and one important point, please do not consider these coefficients. Okay, 2, here it is 2. Okay, it could be anything. Okay, do not consider the coefficients. Your concentration should be only on the input values. Okay, you just don't consider about the coefficients and problems pertaining to this. Okay, let us see another example. Y of n equal to e to the power of minus n plus 1 into x of n. Okay, see, this is a coefficient. You need not consider about this. Okay, and here 2 is a coefficient. Okay, if this is a coefficient, it is similar to above sum, right? So this is also a static system. Okay, I have written down on this sum because you should not get confused during your exam. Okay, that is the reason I have written this particular sum. Okay, this is a coefficient. You should not consider this. Okay, your concentration should be only on the input. Okay. Fine. Let us see another example. Y of n equal to x of sin n. Okay. See, when you see trigonometric functions, you have to pass values like this. It is easy. 0, minus pi and pi. Okay. So what do we get? If we pass n equal to 0, x of sine 0. Okay. What do you get? X of 0. Right? Because sine 0 is 0. Fine. And if you pass pi, what do you get? X of sine pi. Okay. So what is sine pi? Sine any pi is 0. Okay. That we know, right? Because sine n pi equal to 0. Fine. So sine pi is 0. So you get x of 0. Okay. If you see here 0, it depends on 0. Okay. So I can say it is a static system. Okay, fine, static system. Now I am again passing another value, pi. Okay, what I am getting? 0, pi, minus pi. Okay, I am passing pi, but I am getting 0. So 0 is passed for pi. Okay, so output here, it depends on the passed input. So this particular system is dynamic system. Okay, that is why I told you while solving first sum, it is always better to pass values like n equal to 0, minus 1, 1, 2, minus 2 for non-trigonometric sums, and with trigonometric sums you have to pass values n equal to 0, minus pi, pi, and then you have to conclude whether it is a static system or dynamic system. If you find out it is a dynamic system, you have to stop there. Okay, and if you conclude it is a static system, it is better to pass all the values and conclude because it gives accurate result. Okay, fine. Now let us see another example. Y of n equal to x of n plus x star of n by 2. Okay, you have to pass values like this, right? 0, 1, minus 1, 2, minus 2. When I pass 0, what I get? X of 0 plus x star of 0 by 2. Okay, see, you need not consider about these coefficients. Okay, by 2, this conjugate sign you need not consider. You put your concentration only on the input and you decide if it is a static or dynamic. Okay, see here output is at 0. It depends on 0 only. Okay, so it is a static system. You can pass all the other values, you get the result as static system only. Okay, you can try for yourself. Now the final sum, y of n equal to minus infinity to n x of n. Okay, we can write this as y of n equal to x of n plus x of n minus 1 plus x of n minus 2, and it goes on like this, right? And this particular equation, system equation, it is similar to problem number 1, and we had concluded this is a dynamic system, right? Okay, so same, this is dynamic system. Okay, I had written this because I would want you to know we can resolve this integration like this. And this particular thing, it is similar to problem number 1. We had already solved it. You can refer it. Okay. So it is very easy. Right. So now we understand how to find whether the given system equation, it is a static system or dynamic system. Okay. And if you find this video useful, please hit like and don't forget to hit subscribe button so that you won't miss any engineering EEE videos. Okay, and if you have any doubts, please leave it in the comment section. Thank you.